Let us now recap provisioners in Terraform. Provisioners provide a way for us to carry out tasks such as running commands or scripts on remote resources or locally on the machine where Terraform is installed. For example, to run a bash script after a resource is created, we can make use of the remote exec provisioner. Using the same web server example that we have seen many times so far, we can pass in an inline script like this. As you can see from this example, the provisioner block goes directly inside a resource block. These commands in the inline list will now be run on the remote instance after it is deployed. In this example, we are running an apt update, installing, enabling and starting Nginx on the EC2 instance after it is deployed. However, keep a note that merely specifying the provisioner block with a script will not guarantee that the commands will work. For it to work, there should be network connectivity between the local machine and the remote instance. For Linux instances, this means an SSH connection, and if it's Windows, WinRM connectivity should be established. Now this can be achieved by making use of appropriate security groups while creating the remote resources. In this case, we are creating the security group resource, but it could also be an existing security group that's already available in the AWS account. There should also be authentication mechanism that can be used to connect to these instances. Most commonly, an SSH key pair that can be used to access the instance. Again, in this example, we are using an SSH key pair in the resource definition. Now this key is created by the AWS key pair resource, but it could also be an existing key pair which is available in the account. To facilitate the authentication, we can make use of the connection block like this. This is an example of a Linux-based AMI. As such, the connection type is set to SSH. The host argument is where we specify the public IP address of the instance that was created. And since we are operating directly inside the resource block, we can make use of an expression self.publicip like this. This will effectively translate into the public IP address of the instance that was provisioned. The user in this case is Ubuntu, as that's the default user created within this AMI, and the key we use to connect to is the private key. Remember that earlier we used the public key pair as an argument while creating the resource. Now, when we run Terraform apply, we should see the remote exec provisioner connecting to the instance using the details in the connection block and completing the task specified in the inline list. Next, let's take a look at the local exec provisioner. Local exec provisioner is used to run tasks on the local machine where we are running the Terraform binary, and not on the resources which are created by Terraform. This is especially handy when we want to gather some data and write into a file locally. For example, if we want to store the public IP address of the EC2 instance that was just provisioned into a file called ip.txt in the /temp file system, we can run the local exec provisioner like this. And just like we saw with the remote exec provisioner, the provisioner block for local exec also goes inside the resource block. Once the resource is created after a Terraform apply, we can see the public IP address recorded into the file. By default, provisioners are run after the resources are created. This is the default behavior and it is called as a create time provisioner. We can also make the provisioner run before a resource is destroyed. This is called a destroy time provisioner. Now this can be specifically set by making use of the when argument and specifying its value as destroy within the provisioner block. Another default behavior of provisioner is that if the command or script within the provisioner block fails, the Terraform apply operation also errors out. In this example, an incorrect path used in the command causes the script to fail and results in an error. This is the default provisioner behavior, but it can also be set by specifically mentioning onFailure argument inside the provisioner block like this. Any resource that is created while the provisioner fails is marked as tainted within Terraform. For the Terraform apply operation to not fail and the resource to be created successfully, even if the provisioner command or script fails, we can set the value of the onFailure argument to continue like this. As a best practice, Terraform recommends to use provisioners as a last resort. Wherever possible, make use of options natively available for resource types for the provider used. For example, use user data while creating an EC2 instance in AWS, and custom data for Azure virtual machines, metadata for GCP, etc.